Hi guys, how are you today? I'm going to solve question number 22 in section 2, which is thermodynamics. I hope that I solve all the questions and I need from all of you to go on my channel and subscribe, like, comment on the videos. Now, we should read the question out and make a schedule to find the noun and the unknown. So the noun and the unknown. So the things that we know and things that we don't know. The nouns is he said in this question, a steel plant operator wishes to change or it needs to change 100 kilogram of 25 Celsius iron. So what is the material is iron. So we need to use in this question the specific heat of iron, the heat of fusion of iron, everything of iron, not for water, but we use this schedule as before as to show you how we use it. It's the same steps but different temperature, different melting point, and different things to do in here. So it's for iron. Yeah. After that, he said 100 kilograms. So the mass would equal to 100 kilogram. And it would be of 25 Celsius iron into molten iron. So it starts at 25 Celsius of iron. So initial temperature would equal to 25 Celsius. And T final would equal to T final would equal to 15 15.38 Celsius. So suppose this is the starting point that they start is different from the ice and from the water, and this is the starting of melting point. So the melting point is 1538, and here at the bottom, which is the starting initial temperature, it's 25 Celsius. From here to here, we need to calculate. It's different from water, but the same steps of melting of the iron. So, how much thermal energy is added? Must be added. So, what is the needed in this question? They need the thermal energy, which is thermal energy, which equal to the heat. So, how much heat does it need? Okay. After that, we need to draw the steps of the iron. The iron, first it was iron like solid iron at 25 Celsius temperature. Then it goes to the other step, which is 153.8 of Celsius of iron, and then it will be from this step. It will be from 153.8 Celsius to molten point of the molten point of 15.38 Celsius. And then we finish the step. It's an iron. After that, the final step is the calculation step. It will equal to Q equal to MC delta T. So Q would equal to what is the mass? The mass is here. I will change the color to see it clearly. The mass is 100 kilogram. Multiply what is the C, specific heat of iron. Specific heat of iron is equal to 450. And what is the total temperature? The total temperature would equal to, I would write it in here, it would equal to 1,5 from the final temperature minus the initial temperature, and it would be equal to this 25. This is the equation, and then Q would equal to, after solving it in calculator, the answer would be the answer would be 6.8 multiplied by 10 raised to 7. 6.8 multiplied by 10 raised to 7 joules. Not only that step, here it starts to melt, but here it needs to be molten. So it will convert to molten iron like they want. So here we're gonna use heat of fusion. Before we use that, we go here and make it smaller than this to have an area to solve. Okay, we make it smaller, 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 and then it would be in here like that. Same the steps, and we gonna solve the other question, which is here, the other part of question. I will change also the color to see it also clearly. So Q would equal to, like I said before, m H of fusion, or heat of fusion. So the Q would equal to the mass of 100 kilogram, which is here, multiplied by what is the heat of fusion of this iron. I'm gonna look at it at a moment. Wait for a moment. What is the heat of fusion of the iron? Here it is. Iron heat of fusion. It has the heat of fusion of 2.66 multiplied by 10 raised to 5. 2.66 multiplied by 10 raised to the power of 5, and then Q total would equal, not Q total, Q for the second one would equal to 2.6 multiplied by 10 raised to 7. 2.6 multiplied by 10 raised to 7. This is the second Q, and that is the first Q of our question. And then we have these two Q's, and we will add them together to find the final one in other color. So Q total would equal to 6.8 multiplied by 10 raised to 7 plus 2.6. It will be here 2.6 multiplied by 10 raised to 7, and the total answer would be 9.4 multiplied by 10 raised to 7. 9.4 multiplied by 10 raised to 7 joules. So this is the thermal energy that we need from the unknowns. Here we found it. It's so clear, and now you can do it. Okay, thank you guys for watching this video, and don't forget to like, subscribe, comment on my videos in my channel.